This video is going to work on modeling and solving a situation using a quadratic equation. And this video specifically is going to work on maximizing revenue type problems.
So let's walk through this example together. Here we see that a monthly teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each $1 increase in price, the magazine loses 2,000 subscribers. How much should the magazine charge to maximize its annual revenue, and what is the annual revenue at this time? So before we even start to write an equation for this situation, let's talk about how revenue is calculated. And revenue is calculated by taking the price of a subscription and multiplying it by the number of subscribers. So what we know here is we first know that one situation that exists is that we charge $20 for our magazine and we end up with 48,000 subscribers. And what we also know is that for every $1 we add, we are going to lose 2,000 subscribers. So I'm going to create some variables to help me create my equation. So here I'm going to have R, which represents the annual revenue. And then I'm going to have X, which represents the number of dollars I add to my price. So this is beyond the original 20 starting mark. So my revenue is calculated by taking my price, which my price is $20 plus some X value. So this is the price of my particular magazine. And it's $20, or it's $20 plus some value that I've decided to add on to it. So remember, X is the number of dollars that we've added on beyond 20. And it's 20 plus X times my number of subscribers, which is going to be 48,000 minus 2,000X. Because remember, we're going to lose 2,000 subscribers for every $1 that we add beyond $20. So that's our equation here. Our revenue equals the price times the number of subscribers, which in this case, the price is 20 plus some X value that we're going to add on to it. And our number of subscribers is 48,000 minus 2,000 subscribers per dollar that we add on. So now that I have my equation here, let's use this equation to our advantage to help us analyze this situation so we can find the maximum revenue. So I know that I'm going to have a parabola that either opens up or down. And looking at this situation, what I notice is that because I'm looking for a maximum revenue charge, odds are that I have a parabola that is opening downwards because it needs to have some sort of maximum point. So I can figure that this is going to be opening downwards and it's going to have that maximum top point. Now from here, I don't know what's going on, but what I do know is that at some point, this parabola most likely is crossing the x-axis. And when I'm crossing the x-axis, that's where y is equal to 0. And what's nice about those x-intercept points is I know that the vertex point that I need to find my maximum revenue occurs right in the middle of those two x-intercept points. So if I can find those two x-intercept points, I can then average them and find this middle vertex point between them. So what I'm going to do is I'm going to solve for the x-intercepts here. Remember, when we solve for the x-intercepts, our y value is set equal to 0, which in this case is equal to r. So what we can do here is we can take our entire equation of 20 plus x times 48,000 minus 2,000x, and we can set that equal to 0, and that will help us to identify these x-intercept points. Now what I notice here is the form that this is written in is perfect for the zero product property. It's already factored. So what I can do is I can set each little part equal to 0, so I have 20 plus x is equal to 0. So that becomes minus 20 minus 20. So I have x is equal to a negative 20. And then from here, I can also set 48,000 minus 2000x equal to 0. I'm going to subtract 48,000 from each side. So I have negative 2,000x is equal to negative 48,000. Divide by negative 2,000, and I find that x is equal to 24. So what I notice here is that my graph here really isn't that accurate. And so I'm going to draw a new graph here, the new coordinate plane, and I'm going to kind of estimate where my x-intercepts lie. Here I can see I have an x-intercept at negative 20 and an x-intercept at 24. So if I draw this coordinate plane, I can estimate that I have, so I'm going to do 5, 10, 15, 20, and then 5, 10, 15, 20, 25, so that's going to be about right there at 24. So I've got something that looks like that. That's my quadratic there. And what I need to find is I need to find what this vertex point is in the middle. So in order to find our vertex point, what we're going to do is we're going to average our two x-intercepts because we want to find the number that is exactly in between. To find an average, we add the two numbers together, so negative 20 plus 24, and we divide those two numbers by 2. So negative 20 plus 24 is 4. 4 divided by 2 is equal to 2. So I know that my vertex point up here has an x-coordinate of 2. And that 2 represents the number of dollars that we added onto our price. So what that's telling us here is the best price, the price that yields the maximum revenue, is going to be $20 plus 2, which is going to be a price of $22. That's when our maximum revenue is going to occur. Now, in order to figure out what that maximum revenue is, we have to take our x value of 2, and we have to substitute it into our equation here. So we have our revenue equation. So 20 plus 2 becomes 22. 48,000 minus 2,000 times 2 becomes 48,000 minus, that's 4,000. So that becomes 44,000. And if we multiply those two numbers together, we find that our maximum profit when we have a price of $22 is going to be a revenue of $968,000.
Now, just a little bit of extra information for those of you who like seeing all of the patterns and parabolas. We also could have solved this using other strategies that we've learned. So we've talked about how we set this equal to 0 up here and we solved. If you wanted to, you could multiply this all out and use one of your other strategies. Now, obviously, that's not probably the most ideal situation because you're going to have a lot more math going on, but you could, if you wanted to, multiply all of this out and you would get a quadratic and use something like completing the square or the quadratic formula or something like that. You also, if you forget how the zero product property works, you also could multiply all this out and get your standard form, your ax squared plus bx plus c form. And in order to find that 2, you could also use x equals negative b over 2 times a. So you have a lot of options here when you're solving this type of problem. Now, obviously, using the zero product property when it's already set up that way is the easiest option. But if for some reason you did not remember that, you could use other strategies like the quadratic formula, completing the square, or even getting it into standard form and using x equals negative b over 2a to find that x value of your vertex. So you have a lot of options if you do forget, but just note that they all kind of tie together to find that same thing of that maximum price and that maximum revenue point.